For the last 10 days, 41 lives in Uttarkashi's tunnels are trapped. Administration is trying hard to rescue them. So, to discuss more, I'm joined by Vivek Padmanabha, professor at IIT Guwahati in the Department of Civil Engineering. Good morning, sir, and welcome to India today. So, first question to you is what was the reason behind this collapse and what led to this accident, sir? This tunnel collapse and accident.
Okay, good morning. Thanks for having me here. Let's see why do the tunnel collapse. Okay, so first, so we know this soil and rocks in the earth crust, they have been subjected to tremendous amount of pressures. So what we call as the geostress, or most simply, we call it as a geostatic stress. Okay, so these stress are in equilibrium and in balance. So when you try to drill a tunnel through this, basically you're trying to create a hole in the earth crust. Okay, so that is disturbs this equilibrium state. Okay, so the rocks around this will now try to recalibrate itself such that it would maintain equilibrium. Some rocks adapt well and some rocks do not. Okay, so apparently the rocks in our Uttarkashi site, the Silhari site, has not adapted well, right? So that is why we have this mishap, and that is why we are here, and that is why we are discussing, right? Okay, so now the reason for the collapse. What I could see, of course, this is based on the readings which I have done. So what I could see, there could possibly be three issues. The foremost is lack of geological adaptness. Okay, so the knowledge of geology of the site is crucial. Okay, we need to know what type of rocks, nature of discontinuities, faults, joints, and so on and so forth, and then how these rock behave against the dynamic loading. For instance, blasting and drilling. Okay, so these informations are vital for the design, which brings us to the second possible issue, which would be improper design and faulty construction practice. So where we have compromised on the safety protocols. Okay, so that would be the second possible. And the third one would be the lack of excavation or remediation plan. Okay, so what happens in spite of having a thorough preparedness on the site conditions and the design, yet we would not have the same ideal conditions in the site because we are dealing with the rocks which are highly heterogeneous and anisotropic. So what we need to do in the site is we have to continuously monitor the site as we progress in drilling. Okay, so that's where we would look for the potential damage zones as we progress. So we would be cautious if we find any sort of disturbance. There are like different mechanisms to predict that, and we would give a support systems to counter these resisting forces. So I possibly think the third one would be most possible reason which the collapse would have happened, where they didn't have a possible system to foresee this collapse, provided of course the design has to be intact and the safety protocols has to be taken care. Yes.
Professor Padmanabha, please also explain the basic geography of the region as well as what kind of rocks are found there. What is the basic geology and geography of the region, the Uttarkashi region where the tunnel is situated and where the
Right.
accident took place?
Okay. Personally, I have not been to this specific site, that is the Pelhari site, but I have been to Uttarkashi, and with the geological information which we have, I see this site is located in the Lesser Himalayan zone. Okay, and this zone is close to the main central thrust. So this zone will have predominantly sedimentary and metasedimentary rocks. That would include limestone, slate, and phyllite. Phyllite is a metasedimentary rock where metamorphism happens over slate. Metamorphism is when these rocks are subjected to very high pressure and temperature over years, they transform into a new rock. That's where we got phyllite. So these phyllites are small grained rocks which will have small grains, and they are tend to be much softer. When I say soft, it is the compressive strength. The strength of the rock is much lower when compared to the other rocks, for instance, basalt or granite. The compressive strength of phyllite or these rocks would be around 10 to 30 MPa. So we are dealing with soft rocks. So tunneling in the soft rocks is quite challenging, and appropriate steps need to be taken when we do so.
Okay. Professor Padmanabha, what methods authorities are using to rescue these guys, those who are trapped in the tunnel? What
Okay,
methods like vertical drilling? They're using other methods
right,
also.
right. Right. So yeah, as we are aware with the demographic, we have this 4.5 kilometer of tunnel, and we have 2.3 kilometers from the Silhara side. And so there is a rubble of about 50 meters width, I believe, 40 to 50 meters width. So one option is you have to drill through this rubble. But then when you try to do that, basically you're trying to excavate these rocks, you're altering the stress state. So you are exposing the rocks to a much unstable conditions. That would not be the wise option. I think recently they tried to do this horizontal drilling through this rubble, and they found crackling sound, which made them to stop this process. The other option is from the Barkat site, where they have to drill the unearthed portion, which is about 400 meters, I believe. So that would be again, we already know this rock is vulnerable, so further excavating will not be again a good option. So the third option is to vertically drill. So what is vertical drilling? So that's because we are all curious to know on that front. So vertical drilling is very simple. It's a process in which we drill a borehole right on the down the earth surface. Okay, creating a vertical shaft into the earth. From the context of rescue operation, basically we are providing a direct access to the leading the trapped site, where we can give for ventilation, communication, or even if the borehole is wide enough, we can have the personals evacuated from the bore vertical drilling. The most important thing here is why is vertical drilling more advantageous when compared to the horizontal drilling, right? So why we prefer this drilling? So as I said in the initial discussion, the rocks are subjected to stresses, which we call geostresses, geopressures, right? So these pressures would be different at different directions. So the vertical stress will have the maximum pressure. So this maximum pressure in the vertical, which the rock experiences, we call it as the maximum principal stresses. So if we have our drilling along this or aligned along this, the direction of the maximum principal stress, we will have the least disturbance on the tunnel opening. So this is one of the reason why they would have adopted for this technique, so that we don't have much what do you say, the conditions, we don't alter much conditions onto the surrounding rocks. But of course, this preparedness we have to come with, because these we are dealing soft rocks. These rocks can cave in and fall back into these vertical drill bore wells. But of course, we have the casing systems. That's what we generally do for any bore wells also. We add casing. So these casing will prevent the rocks from falling back into the well. So as we progressively drill, we will have this casing inserted. So that would possibly avoid the falling of the debris into the well. So that was a wise option. We look forward to that drilling.
Sir, when was the last time this vertical drilling method was used in a rescue like this, when someone or some life was trapped in a tunnel?
Right. Yes, vertical drilling is quite a popular rescue operation method, especially in the mines. So in mines, especially recently, I see that there's a mine in Shaanxi in China. So in 2010, around 153 people were stranded. It's a mine workers inside the mine area. So this was not a tunnel collapse, but it was tunnel flooding, where the water started seeping into the mine area, and all these people were left in a flood state. So that time they had used vertical drilling approach, and they were successfully able to rescue all the 153 personals.
Okay. What could be done to uh, uh, prevent the accident, which is like the Silkyara tunnel accident or any other accident which took place in tunnels or while
Right,
mining? What
right.
precautionary steps one should take while tunneling or while mining?
Right. Yeah, that's a very important question at this hour, because as we see, the most simple answer would be to strictly follow the design guidelines and safety protocols, right? So that would be the most simple answer, I would say. But of course, the need not to say that the safety protocol is paramount. We shouldn't compromise this at any stage. But what is more beneficial from the research point of view, I would say, is if we are able to predict the damage of the rocks prior to the drilling or as we drill. Okay, so that would be quite advantageous to know as prior whether we can go forward or should we stop at this stage. So that's where the real-time monitoring system comes into picture. This technology is already in place with the tunnels and mining divisions, but then how accurate these predictions are is the questionable. So several researchers are working on it. We are also working on in IIT Guwahati. So we are currently involving in developing a dynamic control theory where to predict the rock burst using artificial intelligence. So where this is based on the uh, like a temporal spectral evolution of the seismic data which we record from the sensors mounted around the mining zone. So such studies would reinforce or which would help us to predict more accurately the damage evolution which happens during the drilling or blasting operations. So this would, I believe, would help us uh, uh, avoid such mishaps in the future.
Thank you, Professor. So this was Professor Vivek Padmanabha from Department of Civil Engineering, IIT Guwahati, who clearly explained us the reason behind this accident, how one could prevent the accident like this, and what methods currently administration is using to rescue the 41 lives which are trapped in the Silkyara tunnel in Uttarkashi, in Uttarakhand. Done, sir. Done.
Okay. Thank you. Huh?
Okay, okay,
Was it
okay.
fine?
Thank you. Thank you. Yeah.